So today's December 2nd, and we're looking at solving equations for the first time that have variables on both sides of the equal sign. It's up to you whether you want to copy down this first slide or not. We're just going to use this to talk about and think about. If you want to, you can, but you don't have to. You will often hear math teachers talking about how an equation is like a balance. This shows you a picture of what we're really talking about. This balance here represents the problem 3x on the left side and 4 plus x on the right side. It's balanced. The left is equal to the right. Can you use this picture to kind of think of a way you could figure out what x is? I'm going to pause this, and I want you to talk to your partner. All right, Jack, what do you guys think?
X equals 2.
How did you arrive at that?
Because you can cancel out an x on, or you can start by canceling out an x on either side.
Do you guys see that you can, like, there's an x on both sides, they kind of cancel each other out, or you could think of, you could take them both off, right? In your mind, it might look something like this. You're taking an x off of both sides. It stays balanced. And then what relationship do you know when you do that, Jack?
Because then 2x equals 4.
And so therefore, x must be 2. All right, very good. So this is kind of like a visual picture that you could have. When you have variable terms on both sides of the equation, we have to simplify it by removing them from one side. So we only have variables to deal with on one side. And that's good. You just have to make sure that if you do something to one side, you do the same thing to the other side. Did you have a question, Michael?
No, I was just going to say that they have 2 right hands.
Oh, all right. Moving on. Now, anyone have any questions about this? We're not going to draw scales for all of these, but this is the idea. So let's start by looking at our next equation without a picture. The directions here are to solve and check, and the equation is 5x plus 3 equals 3x minus 7. So you can see you got variable terms on both sides, right? We don't want that, so we want to remove the variable terms, eliminate them on one side of the equation. What do you want to eliminate, Mike?
You're going to eliminate 3 by subtracting 3 from both sides.
Do you mean just the plain 3 or the 3x? Because we want to take care of the variable terms first.
And you want to subtract 3x from each side.
Yep. So we want to remove it. This is a logical choice to remove it from the right side. We could remove it from the left side, but and you get the same answer, but let's get rid of the 3x. It's a positive 3x, so you can subtract 3x away. Subtracting 3x is the same as doing what? Anna?
Adding negative.
3x, yeah, good. So that's how I'm going to show it, because a lot of kids like it that way. It doesn't matter to me. Okay, so this will then simplify. What does the left side of my equation simplify to? Where does it simplify to? Jack?
2x plus 3.
2x plus 3. And the right side of the equation, what does it simplify to? What does that simplify to, Mary?
X plus minus and 3 as in 37.
There's no, what is a positive 3x plus a negative 3x? 0. So what's left over there actually? Just the constant of negative 7. Very good. Yes, Liam?
I don't get how we got the first for the second one.
Yeah, right there.
This line right there?
Yeah.
We have, just like our balance in the first problem, we have variables, x's on both sides. We have 5x on this side and 3x on this side. We need to get rid of them on one side. So Mikey said get rid of the 3x on this side. How can we get rid of 3x? By adding negative 3x.
Oh, okay.
If we take 3x off of that side, we have to do the same thing to this side, keep it balanced. Okay, so then it simplifies to this. So on this line, let's write a note in your notebook. What we did there is we eliminate the variable term from one side of the equation. by adding the opposite. Of course, if you do something on one side, you have to do the same thing on the other side. All right? Then this 2x plus 3 equals -7, that's an equation like you've been solving a lot. So with your partner, go ahead and quickly solve that for x. You just proceed as usual to solve it. Go ahead and do it. Caitlin, what did you do next?
We added an opposite for 3, so
Okay.
it's a 2x plus 3 plus 3.
Get rid of that constant.
-7
Very good. What's your equation simplified to then, Caitlin?
2x plus 3 equals
2x equals -10. And what do you do for your last step, Robbie?
You would just pretty much make it, you would like divide, so it would be 2x equals 2, and equals -10 over 2, and you would get x equals -5.
Very good. X equals -5. All right. Now these directions said to solve and check. Remember that on Tuesday our lesson was about checking your solution. How do we check if x equals -5 is the right solution, or if we've made an error? What did we do to check it? That was what we did on Tuesday before vacation. Anna?
You replace all the variables with the -5.
Yeah, we replace the x's with the -5 and see if we get a true statement. Remember to do it in the original equation. So I'm going to change that into 5. Instead of x, I'm going to substitute in -5. 5 times -5 plus 3. We want to know, does that actually equal 3 times -5 minus 7? So what's 5 times -5, Luke?
-29,
Plus 3 is
-22,
-22 on that side. And 3 times -5, what's that, Mikey?
-2.
3 times -5, -15. -15, yep. And -15 minus 7, Robbie? It's
Oh, no.
-15.
No. Yeah, negative. Oh, no, it would be addition.
-15 plus -7,
22.
-22. Did we get a true statement? Yes, so we know that that's the right solution. Okay? Any questions about that?
No.
Okay, you'll have to check a couple on your homework, but not all of them. The next problem on the next slide is a more detailed one. We'll work through this together, and then the third one I'll have you do with your partners. So let's get down this example 2. 5 times the sum of x and 3 plus 2 times the sum of x and 1 equals 5 minus 4x. All right, one step at a time. What do you think is the first thing we should do? What we should do first here, Daryl?
Distribute.
Distribute. Yep, distribute. Get rid of the parentheses. So what do you get when you distribute, Daryl?
5x plus 15 plus 2x plus 2
Good.
equals 5.
All right. Now, what do you think we should do? What would you want us to do here, Liam?
Change, fractions to adding the opposite.
Oh, I did that. Yep.
Oh,
Good. Yep. And then what? Caitlin?
add like terms.
Yeah, there's like terms on the left side. Simplify that left side by adding like terms. When you do on the left side, what does it simplify to over here? How about Logan?
It simplifies to 7x plus 17.
Very good. And the other side is still just the same. Now we've got a much simpler equation, but we have variables on both sides. We don't want variables on both sides. We're trying to isolate x. We need it to just be on one side. So you need to get rid of one of your x terms. Which one do you want to get rid of? Will?
the one on the right side.
The -4x? Okay, and you can do it either way, but I would go Will's way too, because then I'm just dealing with positive numbers. How do I eliminate a -4x, Will?
And positive 4x.
Yep, which is great. as long as I do it to both sides of my equation. So I've got to add it to the left side and add it to the right side. Now, when we simplify, we should have variables only on one side of the equation. What does the left side over here simplify to, Erna?
11x plus 17.
Good. And what does the right side simplify to? What's the right side simplify to, Logan?
5.
Just 5. We're close now. We're getting near having that x by itself. What should we do next? What do you think, Melaitis?
11x plus 17 plus negative 17, and then same on the opposite side.
Okay, so eliminate that constant by adding the opposite and do it to both sides. What's my equation simplify to now, Mikey?
11, x is equal to negative 12.
Okay, we're almost there. We want to know just what 1x is. Jack,
111, say.
how are you getting it?
Or negative 111. Because you divide 12 by 11, or negative 12 by 11. It doesn't really work, so it's closest you can get without doing decimal. Because decimals are not nice.
Well, and actually the fraction is really exact and accurate. It's improper, so Jack changed it to -1 and 111. And you're right, the decimal would be not nice. All right? That one we didn't have to check, we just solved it. Any questions about the process? Okay, so the next step then is for you and your partner to solve the next problem together. I want you to work through it together. Choose your strategy, which variables you're going to eliminate, do it at the same time. Liam, did you have a question?
Oh, go ahead.
Okay. All right, so here's the one you're working through with your partner. Example 3, 5m minus 8 equals 2 times the difference of 4m and 6. Yeah, Robbie?
Do you want us to solve this x or just
Just solve and then call me over. Okay, here is the final answer to the equation. You solve it, and the steps you've got m equals +1 and 1/3. Okay?